Hello, my name is Robin Huang, and this is my IA application video for EECS 280. Today we'll be talking about pointers. So far we've been making objects on the stack frame, and that's how we've been assigning variables to objects on the stack frame. So we see in these first three lines of code here, int x equals 4, int y equals 18, and char z equals k, that's where we see objects being created on the stack frame and the initialization of variables. And if we look at our stack frame main over here, we have x being assigned to x holding the value 4, y holding the value 18, and z holding the character value k. And every variable and every object on the stack frame contains a memory address, or it is associated with a certain memory address, right? Every variable has to be contained somewhere on memory. And that location where those variables are stored at are known as memory addresses. So it turns out, and it proves to be very useful, that we can use a variable type called a pointer that holds a variable's memory address. So let me say that again. We are trying to create a variable that doesn't hold objects, but holds their memory addresses. So in order to do that, we need to know how to use the ampersand operator, right? So if we look at this line right over here, we have cout ampersand x, right? This ampersand is an ampersand operator, right? When we do not use it with this equals operator, which is also another type of operator, it becomes the ampersand operator. And what that does is, when used with a variable, it returns the memory address of that variable. So ampersand x will return the memory address of that variable. We need to know this because we need to be able to use an operator to get a memory address of a variable so that we can store that memory address in the pointer variable, which we have right here, x pointer equals ampersand x, right? We're using this ampersand to the right of the equals operator, so it's being treated as an ampersand operator so that we can get the memory address of x and store it in the variable x pointer. And we know that x pointer is a variable that is a type int pointer because it is used with this star or asterisk symbol here. This is not to be confused with what we have in this line, which is int ampersand a equals x, where this ampersand is being used on the left-hand side of an equals operator, which in this case, this ampersand doesn't mean assignment operator, it means alias of, right? This is how we make reference variables, right? So if we look at the stack frame over here, a is an alias of x, so it holds the same value. It's just another name for this x value. So when I cout a, I'm going to being cout 4, right? But when I cout ampersand x, I'm going to be couting the memory address of x, which is 0x1002. Okay, we have different pointer types for different variable types. Let me say that again. We have different pointer types for different variable types. So an int pointer is different from a char pointer. This variable type, x pointer's type is int pointer, and z pointer's type is type char pointer. They are different types. They are not both type pointer. It's that x pointer is a type int pointer, and that z pointer is a type char pointer. They both hold memory addresses, but one holds the memory address of a char, and one holds the memory address of an int. When we cout each thing, now this is something important to note. When we do variable assignment, so when that pointer symbol or that asterisk symbol is to the left of the assignment operator, that's how we're declaring that this is a variable that is of type pointer, or type int pointer, or type char pointer. But when we have that asterisk symbol in a different context, like here, we call this the dereference of a pointer. This is different from using the char pointer or the pointer symbol or the asterisk symbol here. This is called the dereference, and what that does is it's saying, look at x pointer. We know that x pointer holds a memory address. Go to that memory address and get me its value. So if we cout x pointer, it's going to cout 0x1002, because x pointer holds the memory address of x, which is 0x1002. But if we see out the dereference of x pointer, it's going to see out it's not going to see out 0x1002. It's going to see out 4, because what we're saying is go to the memory address that you're holding and get whatever value's in there, and that is 4. If we see out the memory address of x pointer, now this is where it can get confusing. We're not going to see out 0x1004. X pointer is its own variable, right? X pointer is a variable that is not x. It's a separate type of variable. So if we see out the ampersand of x pointer, right, it's saying get the memory address of x pointer. That doesn't mean get the memory address of x. It's saying get the memory address of x pointer. And x pointer is stored as 0x1006. So we're going to be seeing out 0x1006, not 0x1002. If we wanted to see out this 0x1002 over here, we would just see out x pointer, because that's the memory address that that variable holds, but x pointer exists at 0x1006. Hope that cleared up pointers, and thank you for watching this video, and have a great day.